Assalamualaikum warahmatullahi wabarakatuh to my fellow panel, Dr. Siti Rabizah binti Makhsin and Dr. Muhammad Afzan bin Muhammad Anuar, and everyone that watching my presentation video. I hope everyone is staying safe during this pandemic situation. Practice 3W and avoid 3C. First of all, let me introduce myself first. My name is Muhamad Farith Nazreen bin Abu Samah. I am from UiT Alam, Faculty of Mechanical Engineering, and for my final year project, I am under supervision Dr. Muhammad Sukri bin Hadi. In this video, I will be presenting about my research PID controller based on bird mating optimizer for vibration suppression of horizontal flexible plate structure. The outlines that I will explain in this presentation are project background, problem statement, objective, scope of work, literature review, project methodology, expected result, and the project planning. Let's start with the introduction of this presentation, which is the project background. Previously, the industry chose the rigid structure in their application. Why they choose the rigid structure? Because the rigid structure have less unwanted vibration, because they are heavyweight and robust characteristic. However, the heavyweight of the structure affected the system, which can lower the speed of operation and high energy consumption. Because of that, currently industry turn to flexible structure that widely used in engineering application. The flexible structure consists of various elements such as plate, shells, beam, and manipulator. And the flexible plate structure are the most commonly used by industry compared to other elements of flexible structure. Opposite to the rigid structure, the flexible plate structure offers several advantages to industry, such as lightweight, high efficiency, and low energy consumption. Due to the lightweight of the structure are exposed to the excessive vibration in system that could negatively affect to the system and surrounding. In vibration control system, there are two methods, which are passive vibration control system and active vibration control system. The passive vibration control system consists of passive elements such as damper to control the vibration of system. This method is suitable for the high frequency system. For the active vibration control system, this method advantage are high effectiveness when applied and economical to system. This method minimizes the structure vibration by producing secondary source based on a wave element and suitable for low frequency system. This method is suitable for flexible plate structure since the structure system is low frequency. For modeling system, currently most researchers turn to system identification method to obtain the accurate model of system to eliminate the undesired vibration in system. There are few types of system identification which are conventional, intelligent algorithm, and many more. The problem statement consists two sections, which are the flexible plate structure and passive vibration control system. As we know, industry currently turn to flexible plate structure. However, the lightweight of structure affected the performance, which can cause the undesired vibration on system. Due to the lightweight characteristic, the structure are easily affected by the external disturbances and could give the negative effects such as human discomfort, system damage, and reduced system performance. For the passive vibration control system, this method requires passive element, and the element increase the weight and the cost, especially on the transportation. This method is also suitable for the high frequency only, and not suitable for the flexible plate structure, since the structure system are low frequency. An example of a failed vibration control system in reality is the Millennium Bridge in London. The Millennium Bridge London was opened to public on 2000. However, the pedestrian having swaying motion on the bridge during the opening day. At that time, the maximum capacity of the bridge at one time is 5,000 people and only 2,000 pedestrians on the bridge during the incident. The bridge was closed for maintenance after the incident. The research was conducted to investigate the factor of incident. From the research, it's found out that the design of the bridge do not consider any mode of vibration that causes the excessive vibration on system. The bridge system also have low frequency and is required to have proper vibration control in the structure system. The bridge was reopened back to public on 2002. This video is show the incident where the pedestrian having swaying motion on the Millennium Bridge during the opening day. The objective of this project are to develop an accurate model of horizontal flexible plate structure using system identification method based on recursive least square and bird mating optimizer. The next objective is to design and simulate the PID controller for vibration suppression of the horizontal flexible plate structure. Based on the objective, there are 6 scopes of study. The first scope is the modeling horizontal flexible structure using the system identification method based on recursive least square and bird mating optimizer algorithm. Then, the developed model validated using mean square error, pole zero stability, and the correlation test. Next, the objective of bird mating optimizer algorithm are restricted to only single objective function referred to lowest mean square error. Other than that, the implementation the PID controller based on the active vibration control method. Next, the PID controller parameter is tuned using the heuristic method for vibration control purpose. The last scope of study is develop PID controller assessment is limited to 2 disturbances which are single and multiple sinusoidal. Next, we proceed to the literature review. This literature review consists 3 main topics which are flexible plate structure, modeling and vibration control of flexible plate structure. The first main topic on this literature review is the flexible plate structure. After the literature review on this topic was conducted, it's found out that the flexible plate structure are the most commonly used in industry after the rigid structure. This structure offers several advantages to the industry such as lightweight, low energy consumption, and high efficiency. However, the lightweight characteristic causes the undesired vibration on system. This advantage and disadvantage of the structure attract researchers to apply the flexible plate in their research study. For example, G and Deng at 2018 has studied the first vibration control on the flexible plate structure. Next, Ogawa and his friend at 2018 will use the disturbances cancellation control method to control the vibration on the flexible plate structure. Thus, for the flexible plate structure, Liao and his friend at 2020 has studied the effect of solitary wave on a flexible plate structure system. The second main topic of this literature review is the modeling of flexible plate structure. The flexible plate structure has a lightweight characteristic compared to rigid structure. However, the lightweight factor may harm the system by the excessive vibration on the system. An accurate model is needed to ensure the controller performs well in suppressing the unwanted vibration on the flexible plate structure system. Finite element method, partial differential, and system aggregation are the example of modeling method in industry. Some researchers had applied the modeling method on their studies. For example, Krisani and her friend at 2020, they will use the finite element method to model the high conductivity material. Next, Cheng and his friend also at 2020 will propose mathematical modeling to obtain dynamic behavior of flexible cantilever plate. Other than that, Wang and his friend will implemented the partial differential equation modeling method to control the vibration on mining cable system. For the subtopic of modeling flexible plate, which is the system identification, most researchers currently apply the system identification method to obtain an accurate model. System identification is a mathematical modeling based on input-output data that collected from the experiment. System identification method has various types which are genetic algorithm, conventional, swarm intelligent algorithm, and many more. Since system identification is the latest method, many researchers attract to develop this method on their application. For example, Shan and his friend will develop filter recursive least square to control the vibration of gear-driven system. Next, Jenning and her friend will use the genetic algorithm to obtain solution when collecting machining data. Aram and his friend will overcome the combinatorial issue by proposing two types of bird mating optimizer algorithm, which are random key BMO and discrete BMO. The last main topic of this literature review is the vibration control of flexible plate structure. It is crucial to eliminate the unwanted vibration from the structure to avoid any damage to the system, such as wear, fatigue, and unstable system configuration. The correct vibration control technique is needed to suppress the undesired vibration on the system. The vibration control consists of methods such as passive vibration control (PVC) and active vibration control (AVC). Most researchers implemented the AVC method due to their high effectiveness and stability of various advanced control systems. For example, Wang and Lee at 2017, they will apply the active vibration control method to eliminate the unwanted vibration on the flexible beam. Also at 2020, Wang and his friend will apply the active vibration control method again to control the vibration on the truncated shell. The subtopic of the vibration control of flexible plate structure is the PID controller. The PID controller offers several advantages in their application, such as easy to use, better performance, and high stability compared to other controllers. It is important to tune the PID controller by using the correct method to obtain a suitable and accurate controller parameter value. The parameter of the controller such as proportional gain Kp, internal gain Kd, Ki, and derivative gain Kd are essential to achieve the best performance of the controller. Most researchers are attracted to apply the PID controller on their studies. For example, Simonovic and his friend have modified the PID controller to obtain the integrated solution. Next, Galbachev and Chelik have proposed a tuner based on the PID controller in active vibration control system of smart beam structure. For the project methodology, the system identification method based on input-output experiment data is used to model the structure system for vibration control purpose. The system identification was developed based on the linear autoregressive with exogenous ARX model. The model's simplicity to use and the ability to estimate the model's accurate parameter identification are the reason why the ARX model is selected. The system identification method that used in this research study are recursively square RLS algorithm and the bird mating optimizer algorithm. Then, the best flexible plate structure model was applied to develop the PID controller for vibration suppression by using the MATLAB 2019. The PID controller is tuned using the heuristic method to obtain the accurate PID controller parameter and achieve the highest performance of controller. This is the flowchart research methodology of this project. In this flowchart, there are two research objectives that need to achieve. The first research objective is started with modeling horizontal flexible plate structure using the system identification method based on recursively square and bird mating algorithm. Then, developed model will validated using mean square error, correlation test, and post-zero stability diagram. The best model structure will obtain the lowest mean square error value, high stability of post-zero diagram, and 95% confidence level on correlation test. After the best model is selected, the first research objective of this project is achieved. Based on the best model selected, PID controller is developed for vibration suppression of flexible plate structure. The developed controller validated using two types of disturbances, which are single and multiple sinusoidal. Once developed controller is validated, the second research objective of this project is achieved. There are four things that are expected to outcome the good result in achieving the objective of this project. The first expected result is horizontal flexible plate structure modeling using recursively square and bird mating optimizer algorithm will obtain an accurate model. Next, the performance of bird mating optimizer algorithm is better compared to recursively square algorithm by obtaining the lowest mean square error, high stability post-zero diagram, and 95% confidence level on correlation test. Next, the best model of flexible structure is used to develop the PID controller in active vibration control system to achieve the highest performance of controller in suppressing the undesired vibration on system. The last expected result of this project is the developed controller performance is evaluated during the cancellation on first mode vibration by using disturbances which are single and multiple sinusoidal. For the FYP1 project planning, the project was planned as shown in the Gantt chart during the 4th week of this semester. After following this Gantt chart, my FYP1 journey is on right track without delayed any activities. I would like to appreciate my supervisor, Dr. Muhammad Sukri Hadi, that always monitored my FYP activity progress in this semester. The project activities for FYP2 in next semester are already planned as shown in the Gantt chart to ensure there are no overload assignment and avoid late due date submission. To ensure the FYP2 is on right track, I will sacrifice my semester break to complete the planned activities of FYP2 during the semester break. If the project is follow the plan as shown in the Gantt chart, the project may end well, inshallah. That's all about my FYP1 proposal presentation. Don't hesitate to contact me on email if any inquiry. I will put my details in this video description. Thank you so much for watching my presentation video. Assalamualaikum.